Good day, everyone. Today we're going to be looking at GAM415 at Southern New Hampshire University. This is our Week 2 project called Stepping Stone Number 1. The objective here is to create a projectile that has a dynamic material instance applied to it, and then when it hits a object set to block all, it will make a splatter on that object using a decal that matches the color of the projectile itself, and it creates a random colored projectile on every time the projectile is spawned. So let's go ahead and demonstrate here first. Hit play. This is the default template for the first player template. So we'll go ahead and pick up the weapon, and then when we shoot, you can see it's very loud on the shooting, but it makes a splash of random color and intensity and size on the wall. I also set up this cool little project here. So the template was to build a block that you walked into and it changed the color, but I just wanted to make it so it changed color when you shoot. Alright, so as you can see, we create a projectile with a dynamic material applied. It randomizes the projectile color and it matches the decal color. So that was step one. Decals. It creates a decal. Each decal is slightly different. There's actually 4 different decals that it pulls from a single texture. It randomizes the splat texture for those decals, and it randomizes the decal color to match the projectile mesh color. That was task number 2. All right, task number 3 is let's take a look at the repository, and then we'll go look at the code. So minimize. Actually, first we'll go through here real quick. So here's the projectile. It is based on the C++ GAM415 projectile class. We create in C++ a collision component sphere, a static mesh, and a projectile movement component is attached to that as well. As you can see, there is no code in here or in the construction. And look at some of the mesh. We have a material. This is my dynamic material instance for actors. And here the big one is the color. And then if you don't want any crazy intensities or opacity, those are set to 1 and 1. When you do your material instance, you can adjust those to be a different value if you want for your particular material instance. For the splat itself, we have a parameter here, just set to just a random value here with the parameter name of color. We have a texture with 4 quadrants. It's a 1024 by 1024, which each section being 512 by 512. Randomizes to splat, so we set our grid 2 by 2 to sub the images. And then we have a frame where we can adjust 0, 1, 2, 3 for 0, 1, 2, 3 on the texture object, and we plug that into opacity. On the selecting the output node here, we set it as deferred decal, and we also set it as translucent. Okay, for the projectile, which is based upon the material DMI actor, this material instance projectile, we go ahead and leave the intensity and opacity at 1, and we set color as the global parameter that we want to adjust, and then this gets applied in C++ to the item, adjusting the color to a random value. For the paint splat, we make no changes here, but we work with material instances for these. That way it doesn't have to recompile the material anytime a change is made. All right, let's take a look at the code. Coming down here, projectile H for declare our sphere component and our projectile movement component. Let's see, by default it already had a collision. I went ahead and added a static mesh. We create a splat base material, and it is of type material instance instead of just material. Since this is under the private category, most of these are private because we're doing it all in C++, and they do not need to be exposed to the blueprints. However, I do want to be able to set them, so edit anywhere, and I want to be able to set them inside the engine for these particular 2 traits here. So we have just a material instance for the splat base material, and the material instance for the projectile base material, which are the 2 things we actually just looked at in the engine. We go ahead and create a class variable, random color, just an F linear color, so 4 variables, red, green, blue, and alpha. And then for the projectile, we create a dynamic material instance, and for the decal, we create a dynamic material instance. And that's all the big changes here. There is a begin play here, which we'll take a look at in a second. Okay, coming over to the C++ file. All right, adding our standard include so we can do our different things. Big note here is the Kismet math. We're going to be using the random float value in there. We also have gameplay statics where we can add a decal. We have our sphere component and our decal component. Okay, looking for non-standard things here. We create our static mesh. We set it to, since the collision component is the root, which we set right here, collision component root, we create the static mesh and we go ahead and attach it to that collision component. Okay, in our begin play, call our super because we're doing an override here. We want all the parent functionality. We call three random values from 0 to 1, float values, to represent our red, green, and blue using our ukismet math library. And then we go ahead and create that random f linear color that we defined in the header file to be our random x, y, and z, or red, green, and blue. And the alpha, we're just going to go ahead and leave that at a static 1. Okay, for checking so that we don't crash, we are checking is projectile base material set inside the blueprint. If it is set, then we go ahead and create a dynamic material based upon that base material. And we go ahead and assign it as our projectile dynamic material. And we go ahead and set the color of that based upon the random, that linear F color that we just created, or F linear color that we just created. If the static mesh is set, then we go ahead and set the material to here. And you need to do these if statements here so that way you don't crash your game. So you just got to check that the values are set within the blueprints. Okay, moving down here on hit. So by default, it has this section here to interact with the physics blocks, but we want to look here at the non-physics blocks. So the first thing we do is we check on that hit the other actor, make sure it's not set to null pointer. But then we also check, make sure the splash base material has been set. If it hasn't been set, then you can get a crash. Because we'll be accessing a sec. Okay, we go ahead and set a float for our frame number, and we're pulling from the Kismet library another random from 0, 1, 2, and 3 for the range, and that'll help us cycle through the 4 different images for the texture. Then we'll go ahead and spawn the decal at the hit location, which was passed in on hit for the F hit result. And then what we do is go ahead and spawn that decal location. We get a world reference to the currently loaded world, or level in this case here. We're using our splat base material. That's why we had to do that check to make sure it has been set. We make a vector for the range. This is going to set the decal size. So we want 20 to 40, so it'll random between 20 and 40. And then get the hit location and get the hit rotation for the normal. And we said that we do not want a lifespan on this. So if you set it at 0 float, it makes it stay indefinitely when you spawn it. We take that decal and we go ahead and create a dynamic material for that decal using our decal dynamic material that we defined in the header file. And then we go ahead and set that to that same random color that we defined earlier in the begin play. And we set the material frame to select the 0, 1, 2, 3 frame number for the texture on which decal pattern to use. And then we go ahead and destroy our projectile at that point there. That does everything that we need to do. So that was our code. It has been commented, lots of comments. Commentary, and one last look. We need to take a look at our Bitbucket. Bitbucket, pull that up. Okay, GAM415. Okay, you can see the products or the items here. Come here to our commits. You can see added the decal, hit decal with color. And that should be that. All right, thanks. Hopefully that covers everything for week 2. Bye.